Good evening, everyone. Today we are going to start a new topic, and the name of the topic is regression analysis. So let's start with regression. In the last class, we have discussed correlation. Correlation and regression both are related to each other in one or another way. Like you have discussed in correlation that the purpose of correlation is to determine the nature, degree and extent of association between two or more variables. Means correlation basically computes whether two variables are related or not. For example, we want to compute whether age and height are related or not. This we can easily done with the help of correlation. Regression go one step ahead. Regression not only determines the nature of association, it basically expresses the relationship in mathematical terms so that you can predict the values as well. So that's why we can say regression is extension of correlation. So if I define regression, so what is regression? Regression is a statistical technique. It's a statistical technique that first thing, it basically studies the nature of association between two variables. So it basically studies nature of relationship between variables. The first thing, relationship between variables. Then second thing, it will express the relationship in mathematical terms. Then express relationship in mathematical terms in the form of equation. So once we got the equation, then we can easily predict in mathematical terms so that we can make predictions, so that we can predict the value of unknown variable. We can predict the value of unknown variable on the basis of given value of known variable. So the main thing is regression helps in prediction, whereas correlation simply defines the extent of relationship. But regression first express the relationship in the form of equation, and with the help of that equation we can easily predict the value of variable as well. So in regression we'll classify the variables as independent variable and dependent variable. So independent variable is that variable which is not affected by any other factor. But dependent variable is one which is affected by change in independent variable. For example, if we say demand and price, we have two variables, one is demand and another is price. We know that demand is dependent on price. So we can say demand is a function of price. So in this case, the price, this is independent variable, and demand, which is dependent variable, the value of demand depends upon the value of price. So first thing, it categorizes which one is dependent and which one is independent. So it studies the relationship. Second thing, it expresses them in the form of equation. So suppose our demand equation is 5p plus minus 200 suppose. So this is my equation. So if I have the value of price, I can easily compute the value of demand. This is called regression. So regression basically helps in predicting the value of dependent variable on the basis of given value of independent variable. So if I say what is the relevance or importance of regression? Relevance of regression. So first thing, it determines the relationship. It basically study the nature of relationship. The first thing, it study nature of relationship. Fine. Second thing, then express in mathematical terms. So ये relationship को, it helps in expressing the relationship in mathematical terms. And when we have expressed the equation in mathematical terms, then we can easily do predictions. So third thing, it helps in predicting the value of unknown variable. Value of unknown variable. So this is basically the relevance, yes, significance of regression. So next we have, after discussing the relevance of regression, we have types of regression. How many types of regression we have? So like in case of correlation, we have classified them in 3 types on the basis of direction of change, on the basis of ratio of change, on the basis of number of variables. In case of regression, we classify them in 2 factors. First one is on the basis of ratio of change, on the basis of ratio of change, and second is on the basis of number of variables. So we classify them in 2 forms. So when we classify on the basis of ratio of change, we have 2 types of regression. One is linear regression and non-linear regression. We have linear regression and second we have non-linear regression. So let's start with linear regression. So as I have already told you, linear means ratio of change. If ratio of change in variables is constant, means change in one variable leads to same change in another variable, or you can say when variable changes in fixed ratio. Variable changes in fixed ratio. Or you can say ratio of change is constant. Ratio of change is constant. Every time it remains the same. And what is ratio of change? Change in x with respect to change in y. If it is constant, this is called linear regression. And linear regression is generally represented by straight line and by linear equation. And non-linear regression means when the ratio of change varies. Yeah, variable changes in different ratio. When variable changes in different ratio. Or you can say ratio of change varies. Change varies. So this is called non-linear regression. So we say if change in x1 upon change in y1 is not equal to change in x2 upon change in y2, that is called non-linear regression. And it is generally represented in the form of quadratic or cubic equation. So this is called non-linear regression. And when we classify them on the basis of number of variables, we have simple regression, we have partial regression, and we have multiple regression. So now we explain each one of them. Simple regression means we have two variables. We have just two variables in which one is dependent and one is independent. One independent and one dependent. Then this is called simple regression. For example, you can say कि height is a function of age. So height is basically determined with the age. There is no other factor. Here age is independent and height is dependent. So this is called simple regression. In case of partial regression, we have more than two variables. More than two variables in which one is dependent and remaining are independent. So we can say demand is a function of price, income, price of related goods. Here price, income and price of related goods all are independent and demand is dependent. But we are considering demand as a function of price only, taking income and price of related goods constant. So this is called partial regression. But multiple regression is again we have more than two variables, one dependent and another independent. But if we are considering demand with price as well, price of related goods as well, income as well, means we are studying the relationship of one dependent variable with more than one independent variable simultaneously. This is called multiple regression. So there is two types of regression. On the basis of ratio of change, we have linear and non-linear regression. And on the basis of number of variables, we have simple regression, partial regression and multiple regression. Now next thing is we have relationship between correlation and regression. Relationship between correlation and regression. So in case of regression, what we'll do, we'll find out regression lines. So in case of regression, basically we compute regression lines or regression equations. What it means, like we have two variables x and y. So if x is dependent and y is independent, we say equation x on y. So this is x is equal to a plus by. With the help of this equation, which line we draw, that is called a line of x on y. And if y is dependent on x, that means here y is dependent and x is independent. So our equation is y equals to a plus bx. So in regression, if we draw the lines on graph, we have two regression lines. One is x on y and another is y on x. So with the help of regression lines, we can compute correlation as well. Now first case is if regression lines coincide each other. Regression lines coincide each other. Coincide each other means this is your x on y and the same equation is y on x. So if regression lines coincide each other means the same equation is x on y and that equation is y on x, means both lie on same points. So this is both equation. That means your correlation coefficient is perfect correlation, either +1 or -1. If it is an upward trend in this format, this is x on y and this is y on x, this is upward, then we'll say correlation is positive perfect correlation. And if it is downward trend this way, this is x on y and this is y on x. So that means your correlation is -1. Like sometimes you have been given an equation 5x minus 3y plus 11 equals to 0. Now with the help of this equation you have to find out correlation coefficient. That means this equation is x on y and the same equation is y on x. If we want to compute x on y, the equation becomes 5x equals to 3y minus 11. And when you want to compute y on x, then it becomes 3y equals to 5x plus 11. In the last class, we have discussed that if you have two equations, then you have to find out the sign of coefficient of x and y. In both the cases, the sign are same. So that means your correlation is perfect positive correlation. And if sign is in opposite direction, then we say it is negative perfect correlation. So first thing is, if regression line coincide each other, that means there is a perfect correlation. If it is an upward trend, then positive perfect. And if it is in downward trend, then it is negative perfect correlation. Second is, if regression lines are perpendicular to each other. If regression lines are perpendicular. Now what it means perpendicular? So perpendicular means they are making 90-degree angle. So suppose this is my diagram. This is my x on y and this is y on x. And they both are creating 90-degree angle. In that case, your coefficient of correlation is 0. That means absence of correlation. And third thing, if regression lines intersect each other at one point. Regression lines intersect each other. At one point. Then in that case, you have to find the distance between the lines. Like suppose, if it is in this way, this is x on y and this is y on x. They all intersect at this point and the distance between x on y is very less. That means high correlation. Fine. And if we say the lines are this way, so they are intersecting at one point and the distance is far, then we can say less correlation. So we can find out the degree on the basis of distance between the lines. If the distance is less, more will be the correlation, and distance is more, less will be the correlation. So this is your relationship between correlation and regression. How you can predict the value of correlation with the help of regression lines. Next we have method of computing regression. How we can compute regression. So there are two methods of computing regression. One is graphical method and second one is algebraic method. So graphical method means we are taking the help of graph. So in case of graphical method, we have just one method and that is scatter diagram. So we have already done, we have to draw regression lines with the help of lines given in mathematical terms, and we have to draw the lines on graph paper on the basis of distance or on the basis of its placement. We can predict the value of correlation, but it's not an accurate method. scatter diagram, it's not an accurate method. That's why we never use scatter diagram to find out regression. So the next method is algebraic method, in which we have two methods. One is least square method and second is regression coefficient method. Regression coefficient method. So we'll discuss both the methods one by one. So first we are discussing least square method. The first method is least square method. So I have already told you that in case of regression, we'll form two equations. So regression equations, we have two regression equations depending upon which one is dependent and independent. So if we have two variables, so x and y, if x is dependent and y is independent, then we have equation x on y. And if y is dependent, x is independent, then we have equation y on x. So make sure when we say x on y, then x is dependent and y is independent. And when we say y on x, we'll say y is dependent and x is independent. Now we have to compute these equations using least square method. So if our equation is x on y, then it is in the form of x equals to a plus b y, where x and y are variables and a and b are constants. So if we find the value of a and b, that will complete our equation. And when we say y on x, then again y equals to c plus dx. Now in the same case, y and x are variables and c and d are constants. Now how we can solve the question using least square method? So for that, you have to memorize certain steps. Now suppose our equation is x equals to a plus by. Whenever you have to apply least square method, you have been given series x and y. So first thing what we'll do, multiply n on both sides. So when we multiply n on both sides, whenever n means number of pairs. So whenever n is multiplied by variable, it becomes summation x. Because x is variable, when we multiply n by x, this becomes summation x. And when we multiply n with constant, this becomes na. Again, when we multiply by with n, this becomes b summation y. Now, this is my first equation, which I have formulated by multiplying n on both sides of the basic equation x equals to a plus by. So when we have formulated this equation x equals to a plus by, now next thing, because we need two variables, value of two variables. So whenever we have to find out two variables, then we need two equations to solve the value or to find out the value of variable. So in the second step, what we'll do, multiply independent variable. Now we multiply independent variable on both sides. On both sides. So in this case, our independent variable is y. That means we multiply y on both sides. So when we multiply summation x with y, we write it in this form, summation xy. And when we multiply na with y, then it becomes a summation y, and y becomes summation y. And when we multiply y with b summation y, this becomes b summation y square. But there is no logic behind that, how we have multiplied it. This is just a way to remember how these two equations we have formulated. The first equation we formulated by multiplying n, and the second equation we might formulated by multiplying independent variable in first equation. Now if we solve both these equations with the help of elimination method, we can easily find out the value of a and b. In the similar case, we can done in this way also. Now first thing is y equals to c plus dx. So we have multiplied n on both sides. When we multiply n on both sides, this becomes summation y equals to nc plus d summation x. This becomes my first equation. Now we have to multiply independent variable, and in this case your independent variable is x. So multiply independent variable on both sides. So when we multiply x, this becomes summation xy equals to c summation x plus d summation x square. So we formulated two equations. Now we can easily find out the equation. Let's do it with the help of a question. Now suppose the question has been given, we have been given two series x and y. Now the values of x and y are, we have been given, this is 1, 2, 3, 4, 5, and we have been given 2, 5, 3, 8, 7. Now my question is, find both regression equations x on y, y on x. Sometimes the question is very particular. They will explain you which one is dependent and which one is independent. In that case, you have to find just one equation. But when the question is silent, they won't give you any information about which one is dependent and which one is independent. In that case, you have to find out both the equations x on y as well as y on x. Now let's solve the equations by using least square method. I have already told you have two equations, x on y and y on x. So the equation is x equals to a plus by. And here equation is y equals to c plus dx. Now first thing is multiply n on both sides. This will apply to both equations, n on both sides. So in this case my equation becomes summation x equals to n a plus b summation y. And in this case it becomes summation y equals to n c plus d summation x. Now second thing is multiply independent variable on both sides. Multiply independent variable on both sides. In first case, my independent variable is y. So we have multiplied y on both sides, then it becomes summation xy, a summation y plus b summation y square. And in this case, my independent is x. This becomes summation xy is equal to c summation x plus d summation x square. Now find out the parameters. We need summation x, summation y, summation xy, summation y square and summation x square. So these values we'll find out with the help of these values. So first summation x. Summation x is 15. Summation y is, this is 7, 10, 18, 25. Next thing we want xy. So xy is 2, 10, 9, 32 and 35. So this becomes 88. This is my summation xy. Next we have to find out x square. 1, 4, 9, 16, 25. So this becomes 55. This is my summation x square. Now next I need to find out y square. Summation y square. So 4, 25, 9, 64 and 49. This becomes 151. Yeah, this is our summation y square. Now we have to put these values into equation. Now if I put the value in first equation, this becomes 15. N is number of pairs, that is 5. 5a plus 25b. This is my first equation. If I simplify it by dividing with 5, my equation becomes a plus 5b equals to 3. So this becomes my first equation. Now my second equation, summation xy is 88, summation y, that is 25a plus 151b. So this is my second equation. Now I have to solve these equations using elimination method. My equations are 25a plus 151b equals to 88. Then a plus 5p equals to 3. So what I'll do, multiply this by 1 and this one by 25. So this becomes 25a plus 151b equals to 88, and then 25a plus 125b is equal to 75. If I subtract it, minus minus minus, this becomes 26p equals to 13. So b is equal to 13 by 26, that is equal to 0.5 or 1 by 2. Now we have to find out the value of a. So a plus 5b. Put the value of b 0.5 equals to 3. So a is equal to 3 minus 2.5. So again we got the value of a 0.5. So my equation is y equals to a plus b. So x equals to a plus by. So x equals to a plus b y. So this becomes my equation. This is x on y. Now if we want to compute y on x, again put the value. Summation y is nc is 5c plus d summation x is 15d and summation y is 25. Again we simplify, this becomes c plus 3d equals to 5. This is my first equation. Now second equation, summation xy, that is 88, is equal to c summation x, that is 15c, plus d summation x square, that is 55d. So now this equation is 15c plus 55d equals to 88. Now similar way, if we want to solve both the equations, we have to use elimination method. So I have multiplied the first equation by 15. So this becomes 15c plus 55d equals to 88. Now second equation is 15c plus 45d is equal to 75. So we have subtracted both. This becomes 10d equals to 13. So d is equal to 1.3. Now putting the value of d in any equation, we get the value of c. c plus 3d equals to 5. c plus 3 into 1.3 equals to 5. c equals to 5 minus 3.9. So value of c is 1.1. So my equation is y is equal to c plus dx. Now this is my equation y on x. Now how we can predict the value? Now suppose you have been given the value of x till 5. If I took the value, I want to find out the value, what will be the value of y when x is equal to 6. So that means we have to compute the value of y when x equals to 6. So we have to put the value of x in y on x. So if I put y x equals to 6, what will be the value of y? So this becomes 7.8 plus 1.1, that is 8.9. This is called prediction. And if we say what will be the value of x when y is equal to 10. So if y is 10, then what is x? So we put the value of y in this equation. So x is 0.5 plus 0.5 into 10. So this becomes 5.5. In this way, you can predict the value of unknown variable on the basis of given value of known variable. This is your first method, that is called least square method. One thing more I'll tell you. Now our equation is x equals to a plus by, that is 0.5 plus 0.5x, and y is equal to, that is 1.1 plus 1.3x. So y is equal to 1.1 plus 1.3x. Now if I put the value of y in this equation, like y is 2, so x is 0.5 plus 0.5 into 2, this becomes 1.5. Now if I say what is value of x when y is 5, so 0.5 plus 0.5 into 5, this is called 3. Now 0.5 plus 0.5 into 3, this becomes 2. This becomes 2. Next is 0.5 plus 0.5 into 8. This becomes 4.5. And next is 0.5 plus 0.5 into 7. That is 4. So this is called actual values of x. Actual values, and this is called estimated value. So that's why we write it in this way, computed value. And you always know summation of x minus xc, that is always equal to 0. This is called error or residue. So if I compute x minus xc, what it means, 2 minus 1.5, that is plus 0.5. 5 minus 3, 2. 3 minus 2, 1. 8 minus, just a second, this is the value of x, sorry, I have computed wrong, error or residue, just a second, hold on. So this is x minus xc, x is 1 and xc is 1.5, so this becomes minus 0.5. 2 minus 3 minus 1, 3 minus 2, 1. 4 minus 4.5 minus 0.5 and 5 minus 4, 1. So if we compute 1 minus 1.5, 2 minus 3, 3 minus 2, 4 minus 4.5, and then we have 5 minus 4. So we have done some mistake in this question. We have 0.5 plus 0.5y. So we have done y is 2, then 1.5, when y is 5, 2.5 plus 0.5, 3, when y is 3, 1.5 plus 0.5, 2, when y is 8, 4 plus 0.5, and 7 5 is 35, 3.5 plus 0.5, 4. So 1 minus 1.5, this is minus 0.5, 2 minus 3, minus 1, 3 minus 2, 1, 4 minus 4.5, and 5 minus 4, 1. So there is some mistake, the total should be 0. Yeah, it's 0. Minus 1, 1, minus 0.5, minus 0.5, this is cancelled by 1. So sum is 0. So this is what we called error or residue. The difference between actual value or observed value, this is called error or residue. And sum of error or residue should always be equal to 0. Similarly, you can compute the y values by putting the value of x 1. So if I put x equals to 1, this becomes 2.4. If we put x equals to 2, 2.6 plus 1.1, that becomes 3.7. If I say x equals to 3, 3.9 plus 1.1, that becomes 5. So 4.3, 5.2 plus 1.3, 6.3, and 6.5 plus 1.1, 7.6. This is the estimated value of y. So I hope this first method is clear to you. This is called least square method. Now second algebraic method is regression equation using regression coefficient method. So this is my second method, regression equation using regression coefficient method. So what is this regression coefficient? I have already told you in case of regression we have two equations, x on y and y on x. So we have two regression coefficients. We have two regression coefficients. One is bxy and another is byx. So what is this bxy and byx? Bxy is regression coefficient of x on y. Regression coefficient of x on y. We can say this is also called slope of x on y. And y on x, the regression coefficient for y on x is byx. So this is regression coefficient of y on x. Sometimes we get confused which one is x on y and which one is y on x. So I'll give you a small tip, xy. When we have written xy, that means this is regression coefficient of x on y. Because the dependent needs care, dependent needs help. So that's why dependent always comes first, independent always comes at the last. So that's why in this case when we say bxy, here x is dependent and y is independent. And when we say b by x, here y is dependent and x is independent because y needs support and that support is given by independent variable. So make sure don't get confused between bxy and byx. Bxy is regression coefficient of x on y and byx is regression coefficient of y on x. This is also called slope of y on x. So we have to compute the value of regression coefficient. So I'll tell you the various methods of computing regression coefficients. First we'll find out how we can formulate the equation using regression coefficient method. So if we want to compute equation x on y, then our equation can be derived as x minus x mean, that is equal to bxy y minus y mean. If we have done line in mathematics, so if we have to formulate the equation of a line, this is the method. And here bxy, instead of bxy we write down m is called slope of line. So in the similar way we find out the regression equation of x on y. X minus x mean equals to bxy y minus y mean. And if we want to formulate equation y on x, then it becomes y minus y mean, that is equal to byx x minus x mean. By putting the value of x mean, y mean and regression coefficient, we can easily find out equation x on y and y on x. Now most important is how we can find out regression coefficients. So we have various methods of computing regression coefficient. As we have discussed various methods in computing correlation, same methods we can use in computing regression coefficients. I have already told you that there are two series. One is ungrouped series and second is grouped series. One is ungrouped and second is grouped series. So in ungrouped series we have individual series only, and in case of grouped series we have discrete as well as continuous series. So as part of your syllabus, as per your syllabus, only ungrouped series is in your syllabus. So we don't need to focus on grouped series. So we are discussing various methods of computing regression coefficient in case of ungrouped series only. So we have four methods. The first method is actual mean method. Actual mean method. So again think when you have to compute actual mean method. This method is used when mean is whole number. Mean is an integer value. In that case you use actual mean method. So it's very easy to find out regression if we learned the various formulas of correlation. Like I have told you in the earlier class, the formula for correlation in case of actual mean method. This is summation xy upon square root of summation x square into summation y square, where x is equal to x minus x mean and y is equal to y minus y mean. So with the help of this formula we can easily find out the formula of regression coefficient bxy and byx. So to find out the value of bxy and byx, the numerator of correlation formula remains the same. That means in numerator we have summation xy, we have summation xy. Now what we have to do in the formula of correlation, we have to remove dependent variable and second thing we have to remove square root. So after removing both the things, in case of bxy our dependent variable is x, that means we have to remove summation x square and we have to remove square root. So the formula for bxy is summation xy upon summation y square. And the formula for byx is summation xy upon summation x square. So this is the formula of regression coefficient in case of actual mean method. Now let's elaborate this with the help of an example. Suppose you have been given question x and y. And the question is 1, 2, 3, 4 and 5. And second thing is 9, 10, 12 and 11. First we have to see this is mean is actual whole mean or not. In this case 9, 9, 18, 2, 20, 2, 3, 4, 5, 51. So it's not there. So we just do a slight modification in the question. Instead of 11, what we do, we make it 15. So I have done this modification in the question. So first thing we have to compute mean, x mean and y mean. So x mean is summation x upon n and y mean is summation y upon n. So summation x is 15 and summation y is, this is 15, 12, 27, 37, 46, 55. So mean of x series is 15 upon 5, that is equal to 3, and mean of y series is 55 upon 5, that is equal to 11. Now second step is we have to find out deviations from actual mean, x minus x mean and y equals to y minus y mean. So if we subtract it from 3, this becomes minus 2, minus 1, 0, 1 and 2. And if we subtract it from 11, minus 2, minus 2, minus 1, 1. So we have 1 and 4. So we have to check that sum of this should always be 0. So this is 0. So this is by x and y. So next thing we need xy, x square and y square. So xy is 4, 2, 0, 1, 8. This becomes 15. X square is 4, 1, 0, 1, 4. This becomes 10. Y square is 4, 1, 1, 16. So this becomes 26. So we have calculated the values of all parameters. So bxy is summation xy upon summation y square. So summation xy is 15 and summation y square is 26. So 15 divided by 26 is, this becomes 0.5769. 0.5769, and if we have to compute byx, this becomes summation xy upon summation x square. So summation xy is 15 and summation x square is 10. This becomes 1.5. Now we got the values of bxy and byx. Now we can formulate the equations. X on y, this is x minus x mean equals to bxy y minus y mean. So x mean is 3, bxy is 0.5769 minus y minus 11. So we have x equals to 0.5769y minus, if we multiply 0.5769 into 11, this becomes minus 6.3459 plus 3. So my equation is x equals to 0.5769y minus 3.3459. This is my x on y. Now if I want to formulate y on x, then y minus y mean equals to b by x minus x mean. So y equals to 1.5x minus 4.5 plus 11. So y equals to 1.5x plus, this becomes 6.5. So this is my equation. So this is how we can formulate equations on the basis of actual mean method. So this is my first method. Now we'll move to the second method. Second method is direct method. So we use direct method when mean is in fractions and items are small. Mean is in fractions and items are small. So in that case we use direct method. So again, first write down the formula for correlation. In case of direct method, our formula is summation xy minus summation x summation y upon n. In the denominator, first we have one variable summation x square minus summation x whole square upon n. Then we have another variable summation y square minus summation y whole square upon n. Now this is the formula for direct method. Now on the basis of this we can formulate the value of bxy and byx. The numerator remains the same, summation xy minus summation x summation y upon n. You have to remove dependent variable and square root. So in this case the dependent variable is x. So you have to remove this x item. So the remaining item is summation y square minus summation y whole square upon n. And if we have formula of b by x, that means summation xy minus summation x summation y upon n. In the denominator we have summation x square minus summation x whole square upon n. So this is the formula for b by x, means regression coefficient of y on x. Now let's solve a question in which we can use this direct method. So suppose the question is, we have been given any one question in which we can use this direct method. Now suppose the question has x, y. So we have been given 2, 4, 6, 8, 10 and 11. And then y is 4, 2, 5, 10, 3, 4. So suppose this is the value. So first thing is you have to find out mean, because mean is required for computing regression equations. So x mean is summation x upon n. So this will be 4, 2, 6, 6, 12, 20, 30, 41. And summation y is 4, 2, 6, 5, 11, 21, 24, 28. So number of items will be 6. So 41 divided by 6, this becomes 6 6 are 36, 5 6 8 are 48, then 26 3s are 18. So 41 divided by 6, this becomes 6.833. And y mean is summation y upon n. So this is 28 upon 6 means 14 upon 3. So this is 4.67. So this is my mean. Now as you know, the mean is in fractions, so and items are small, we'll use direct method. So for direct method we need summation x, summation y, we need xy, we need x square, and we need y square. So xy is 8, 8, 30, 80, 30 and 44. So sum is 8, 8, 16, 4, 20, 2, 3, 5, 13, 16 and 20. So this is 200. For x square we have 4, 16, 36, 64, 100 and 121. So the total of these items are 6, 4, 10, 6, 4, 10, 20, 21, 3, 3, 6, 6, 12, 13, 14, then 3 and 4, this is 441, and y square is 16, 4, 25, 100, 9 and 16. So this becomes 6, 4, 10, 15, 9, 24, 6, 30, 4, 6, 7, 170. So if we want to compute bxy, then formula is summation xy minus summation x summation y upon n. In the denominator we have summation y square minus summation y whole square upon n. So numerator is 200 minus 41 into 28 upon 6. Then denominator summation y square 170 minus summation y whole square upon n. So this becomes 200 minus 41 into 28 divided by 6. So this becomes 191.33. And this is 170 minus 28 square divided by 6. So this becomes 130.67. So in numerator we have 0.67, 9 minus 1, 8 and 0. And in this is 0.33. Then we have 9 and we have 3, 39.33. So dividing 8.67 divided by 39.33, our bxy is 0.22. This is 0.2204. Similarly, if we want to compute byx, this is summation xy minus summation x summation y upon n. In the denominator we have summation x square minus summation x whole square upon n. So if we just check it out, the numerator is same. So the value of numerator is 8.67. So simply write it down 8.67. Just compute the value of denominator. So this is 441 minus 41 whole square upon 6. So first 41 whole square, divide by 6 and subtract this value from 441. So your value is 160.83. So 8.67 divided by 160.83. So 8.67 divided by 160.83, our value is 0.0539, or you can say 0.054. So this is our byx. So now we can formulate the equation x on y, that is x minus x mean equals to bxy 0.22, we can write this as well, y minus 4.67. So this becomes x is equal to 0.22y minus 4.67 into 0.22. So this becomes 1.0274 plus 6.83. So x on y is x equals to 0.22y plus, this is 6, 12 minus 7, 5, 7, no, there is some mistake, 6.83 minus 1.0274. So this becomes 5.8026. So this is x on y. If we want to compute y on x, then y minus y mean equals to 0.54 byx, x minus x mean. So this is y equals to 0.54x minus 6.83 into 0.54. This becomes 3.6882 plus 4.67. So y is equal to 0.54x plus, this is 8, 1, 9, 10, then 16 minus 8, 8, 15 minus 6, 9. So this becomes 0.9819. So if we subtract 4.67 minus 3.6882, this becomes this 0.9818. This is your second method, that is called direct method. Now let's move to the third method, and that is called shortcut or assumed mean method. So this method we applied in those situations when mean is in fractions, and items are large. So in that case we use shortcut or assumed methods. Now in this case, first we compute deviations from assumed mean. So we compute dx is equal to x minus assumed mean of x series, and dy equals to y minus assumed mean of y series. So next thing is how to find out bxy and byx. So first again we write it down, the formula of correlation. This is summation dx dy minus summation dx summation dy upon n. In denominator, first we have x variable, summation dx square minus summation dx whole square upon n, and in y we have summation dy square minus summation dy whole square upon n. So similarly, with the help of this, we can easily find out the value of bxy. So bxy is summation dx dy minus summation dx summation dy upon n. The numerator remains the same. In the denominator, we have just independent variable, that is summation dy square minus summation dy whole square upon n without square root. So similarly, in case of byx, we have again the same numerator, summation dx dy minus summation dx summation dy upon n. And in denominator, we have independent variable, that is x, summation x square minus summation x whole square upon n. But you don't need to write square root. So let's solve it with the help of an example. Now suppose the question is x and y. Fine, we have to use this using shortcut method. So how we can use it using shortcut method? So we have been given 60, 62, 65, 70, 72, 48, 53, 73, 65 and 82. And second we have y series. This is 68, 60, 62, 80, 85, 40, 52, 62, 60 and 81. Now let's compute the deviation from assumed mean. So first thing we have to assume what is the assumed mean of X series and what is the assumed mean of Y series. So let's say the assumed mean of X series is 65 and assumed mean of Y series is, suppose we can say that is, fine, we take it 68. Okay. So let's solve. We have 60 minus 65 minus 5 minus 3, 0, 5, 7. Then 48 minus this is 17. And then 53, this is minus 12. 73, this is 8. 65 is 0 and 82 is 17. So this is my dx. Dx is equal to x minus 65 and this is my dy. So 68 minus 68, 0, minus 8, minus 6, then we have 12, then we have 17, then we have minus 28, we have minus 16, we have minus 6, minus 8, and then we have 13. So this is my dx and dy. First we compute the value of summation dx and summation dy. Summation dx and summation dy. So summation dx is negative value 538, 8, 17, 25, 25, 12, 37. So minus 37. And plus value is 5 plus 7, 12, 12, 8, 20 and 20 plus 17, 37. So this is 0. And if we take this thing, negative value is 8, 6, 14. 14 and 28. 14 and 28, this will be 42. 8, 6, 14. 14, 8, 22. 22 plus 20, 42. 58. 58, 6, 64, 8, 72. So this becomes minus 72 and positive value is 12 plus 17, 29, 29, 3, 32, 42. So this becomes minus 30. Fine. So this is our values. So next thing is we need dx square, dy square and dx dy. So dx square is 25, 9, 0, 25, 49, 17 square 289, 12 square 144, 64 and 17 square is 289. So if we add them 9, 5, 14, 5, 19, 28, 28, 9, 37, 41, 45, 9, 54. 7, 9, 13, 21, 25, 31, 39, 5, 6, 7, 8. So this is 894. Summation dy square 64, 36, 144, 289. Now 28 square, this is 784. 16 square, it's 256, 36, 64 and 169. So sum is 4, 6, 10, 14, 9, 23, 27, 33, 39, 43, 9, 52, 5, 6, 11, 14, 18, 26, 34, 39, 42, 48, 54, 6, 8, 7, 15, 16, 17, 18. So this is 1842. So if there is any calculation mistake, please ignore it. So summation dx dy, this is 0. 24, 0, 60, this is 119, 17, 28, so this becomes 476, 12 into 16, 192, this is minus 48, 0 and 13 sevens are 91, 13 ones are 13, 9, 22. So 17 into 13, that is 221. So now what we have to do, first we have to add them. So 24, 60 minus 48, it's 12. 24 plus 12, 36. 36. So we add them. 36 plus 119 plus 476 plus 192 plus 221. This becomes 1044. So the form value of bxy is summation dx dy minus summation dx summation dy upon n. In the denominator we have summation dy square minus summation dy whole square upon n. So summation dx dy is, the value of summation dx dy is 1044 minus summation dx is 0, summation dy is minus 30 upon n. Number of items will be, how many number of pairs we have? 3, 3, 6, 3, 9, 10. So this is 10 upon, in the denominator summation dy square it's 1842 minus summation dy whole square upon n. So this is 1044 because all these items become 0. Then 1842 minus 30 ka square 900. 900 divided by 10, 90. So this is 1044 upon 251752. So 1044 divided by 1752, this becomes 0.596. This is our bxy. And if we want to compute b by x, the numerator remains the same, that is 1044. Denominator is, I think I have done something wrong. This is summation dy square. So that means this is your byx. Okay, fine, bxy. Okay, now we have to find out b by x. So this becomes 894 minus 0 whole square upon 10. So this becomes 1044 upon 894. So 1044 divided by 894. So this becomes 1.168. So this is the value of b by x. Now we can easily find out the equation. For that, first we have to find out mean of x series and y series. So x mean is a plus summation dx upon n. We can use the same formula, shortcut method. So a is 65 plus 0 upon 10. That means mean of x series is 65. And mean of y series is a is 60. I think we have taken 68. Yeah, 68. So our value is 68 minus 30 upon 10. So this will be again 65. So the mean of both the series is 65. So x on y, that is x minus x mean, is equal to bxy y minus y mean. So x is equal to 0.596y minus 0.596 into 65. This will be the negative one. But when we add 65, so the difference is 26.26 positive. So this is x on y. And when we want to find out y on x, that means y minus y mean equals to 1.168 x minus x mean. So y is equal to 1.168x. Now 1.168 multiplied by 65. This is negative minus 65. So this becomes minus 10.92. This is our y on x. So till now we have computed three values, three methods: regression coefficients using actual mean method, second is direct method, and third one is shortcut method. So it's quite a little bit complex in calculation, but if you understand the concept, it's very much similar to the correlation. So now we have to move to the third method, again shortcut method. In shortcut method we have step deviation method as well. So in case of step deviation method, there is a slight change in the formula. Because in step deviation, we are computing dx as x minus assumed mean of x series upon interval of x series. And dy is y minus assumed mean of y series upon interval of y series. So the formula is now for bxy we have summation dxy. The remaining formula is same, but we have done in the shortcut method. Just one addition. What is that addition? First we write down the normal formula, summation dy square minus summation dy whole square upon n. Now in this formula you have to do just one more thing. The interval of dependent variable is in the numerator and the interval of dependent variable is in the denominator. Similarly, b by x summation dx dy minus summation dx summation dy upon n. Then we have summation dx square minus summation dx whole square upon n. Now again the interval of dependent variable is in the numerator and independent variable is in the denominator. So this is the formula of computing bxy and byx in case of step deviation method. Now let's do one question so that this thing is clear to us. We have been given x and y. Now x is 600, 630, 720, 750 and 800. And y is 1250, 1100, 1300, 1350 and 1500. Now this is my x and y series. So I am computing dx, that is x minus, you can take anything. Suppose I have taken the value x minus 720 upon 10. So this becomes x minus 120 upon 10, that is minus 12, minus 90 upon 10, that is minus 9, 0. So this will be divided by 30 because no, but 800 minus 720, no, we can say divided by 10. So this is minus 12, this is minus 90 upon 10, this is minus 9, 720 upon this 0, 750, 30 upon 10, 3 and 800 is 7, 800 minus 72, 80 upon 10, that is 8. Now dy, y minus 1300 divided by 50. So this becomes minus 1, this becomes minus 200 divided by 50, minus 4, this is 0, 50 divided by 51 and 200 divided by 54. So this is our dx and dy. So we need dx, dy, dx square and dy square. So summation dx is minus 21 plus 11, this is minus 10, this is 0. That means our y mean is 1300. Summation dx dy 12, 36, 0, 3 and 32. So this will be 6 to 8, 3, 11, 2, 13, 2, 3, 5, 3, 8, 83. Summation dx square, this is 144, 81, 0, 9, 64. So this becomes 4, 1, 5, 9, 14, 18. 5, 8, 13, 6, 19, 298. dy square is 1, 16, 0, 1, 16. So this will be 34. So next thing is we have to find out the value of bxy. So bxy is summation dx dy. Now summation dx dy is 83 minus summation dx summation dy upon n, in the denominator summation dy square minus summation dy whole square upon n into, now interval of x, because x is dependent, that is 10, interval of y, that is 50. So this becomes 0, 83 upon 34 into 1 by 5. So this is 83 upon 170. So if I divide 83 divided by 170, this becomes 0.488. 0.488. And if I want to compute b by x, the numerator remains the same, that is 83. In the denominator we have summation dx square 298 minus summation dx whole square upon n into, now interval of y is in numerator and interval of x is in denominator. So this becomes 83 into 5, 298 minus 20. So this becomes 415 divided by 278. So 415 divided by 278, this becomes 1.49. 1.493. So now we can compute x mean as well as y mean. So x mean is a plus summation dx upon n. So a plus summation dx upon n. Assumed mean is, in our first case, assumed mean is 720. So we have 720 a plus summation dx is minus 10 upon n into I, that is 10. So this becomes 720 minus 20, that is 700. And y mean is, we already came to know, it's 1300. So now we have to just form the equation x on y and y on x. So x minus x mean equals to bxy, y minus y mean. So x is equal to 0.488y minus 0.488 into 1300. Okay, this is negative value. We subtract this from 700, so we have plus 65.6. And y minus y mean, that is equal to b by x, x minus x mean. So y is equal to 1.493x. Now 1.493 multiplied by 700, this will be 104. Again when we add 1300, so this becomes plus 254.9. So this is our x on y and y on x. This is how we can find out using step deviation method. Now the fourth method, in correlation we have named it as covariance method, but in case of regression we say the fourth method applied when correlation and standard deviation both are given. So we apply this method in those situations where correlation and standard deviation both are given. So in that case, if we want to find out bxy, so formula is correlation into standard deviation of x upon standard deviation of y. Again, this value of dependent variable is in the numerator and value of independent variable is in the denominator. And if we want to compute b by x, then formula is rxy into standard deviation of y upon standard deviation of x. So this is the formula through which we can compute regression equation of regression coefficient of x and regression coefficient of y. Now let's do a question in which we have been given these parameters. Now suppose the question is, let's take any example. Now this question is, we have been given series x and y. We have been given arithmetic mean of both the series. Arithmetic mean of x is 5 and y is 12. We have been given standard deviation, and standard deviation is 2.6 and 3.6. And we have been given correlation coefficient, and correlation coefficient is 0.7. Now you have to find out both regression equations, and they have said estimate y when x equals to 9 and estimate x when y is equal to 12. So this is the most simplest method because all the parameters has been given and it's very easy to find out regression coefficient. So regression coefficient is correlation into standard deviation of x upon standard deviation of y. So correlation is 0.7, standard deviation of x is 2.6 and standard deviation of y is 3.6. So if we multiply it, 0.7 into 2.6 divided by 3.6, this becomes 0.50, 0.5055 or 5056 you can say. And if you want to compute byx, this is correlation into standard deviation of y upon standard deviation of x. So this is 0.7 into 3.6 upon 2.6. So 0.7 into 3.6 divided by 2.6. This is 0.969. So now we have to formulate equation x on y. So this is x minus x mean 5, bxy that is 0.5056, y minus 12. So equation is x is equal to 0.5056y minus 0.5056 into 12. And then we add 5. So this becomes minus 1.0672. This is x on y. And if we want to compute y on x, then this becomes y minus y mean is equal to byx x minus x mean. So that means y equals to 0.969x minus. If we multiply 969 into 5, this is less than 12. So if we subtract it from 12, our value is plus 7.155. So we have formulated both the equations x on y as well as y on x. So now we have to find out the value of y when x is equal to 9. So it means y is equal to 0.969 into 9 plus 7.155. So this becomes 0.969 into 9 plus 7.155. So this is equal to 15.876. And if we want to estimate x when y equals to 12, so estimate x when y is equal to 12. So put the value of y as 12 minus 1.0672. So this is 0.5056 into 12 minus 1.0672. So this becomes 5. So this is our answer. I hope this is clear to everyone how we have formulated the value. This is a fourth method when correlation and standard deviation are given. In that case, we'll use bxy as correlation into standard deviation of x upon standard deviation of y, and byx is equal to standard deviation of y, correlation into standard deviation of y upon standard deviation of x. Sometimes you have been given question in this format as well. So you must know how to solve this question. You have been given summation x minus 58. This is equal to 46. Summation y minus 58. This is equal to 9. Summation x minus 58. Y minus 58. This is 1095. Summation x minus 58 whole square, this is 3086, and summation y minus 58 whole square, this is equal to 483, and you have to find out the regression equation. So bacha, I have already told you कि when deviations are taken from mean, the sum of deviations is always equal to 0. That means x minus x mean should be 0. But here x minus this is not equal to 0. This means this is not our arithmetic mean, this is our assumed mean. So whenever we have been given assumed mean, we can write down summation x minus a. This is called summation dx. Summation y minus this is called summation dy. If we have been given summation x minus 58, y minus 58, this means this is summation dx, dy. Summation x minus 58 whole square, this means this is summation dx square. This is summation dy square. And this is number of items. So that means you have to apply shortcut method. So for bxy, our formula is summation dx dy minus summation dx summation dy upon n. Then we have summation dy square minus summation dy whole square upon n. So summation dx dy is 1095 minus summation dx summation dy upon n. Summation dy square 483 minus summation dy whole square upon n. So you have to solve this thing. So this becomes 1095 minus 46 into 9 divided by 7. So this will be 59.1429 divided by 483 minus 81 divided by 7. So this will be 11.5714. So this will be 1095 minus 59.1429. So this is 1035.8571 upon 483 minus 11.5714. So this becomes 471.4286. So if you divide both the numbers, 1035.8571 divided by 471.4286, this becomes 2.197. So our value for this is 2.197. So we can take it 2.197 or 2.2. And if we want to compute byx, the numerator remains the same, that is 1035.8571. In the denominator we have summation dx square. Summation dx square is 3086 minus summation dx is 46 whole square upon 7. So we have 1035.8571 divided by 46 whole square divided by 7. And if we subtract it from 3086, we get 2783.3.7143. So if we divide both the numbers, 1035.8571 divided by 2783.7143, so we have 0.37. 0.372. This is b by x. Now the next step is find out mean. So here a plus summation dx upon n. So assume mean of x series is 58 plus summation dx is 46 upon 7. So 46 divided by 7 plus 58. So answer is 64.57. Similarly by mean. Assume mean again is 58 minus 9 upon 7. Sorry, plus 9 upon 7. So 9 divided by 7. So if we add 58, this becomes 59.29, you can say. So now you can easily find out the equations. So equation is x minus x mean equals to bxy y minus y mean. And And if you want to find out y on x, so y minus 59.29, that is equal to b by x minus x mean. So this way you can find out both the equations. Now, sometimes there may be question of like in this way. There may be one more question which you must know. The question is n equals to 10. Summation x equals to 200. Summation y equals to 225. Summation x minus 10. Okay, fine. No, this is not the scenario. I will take another example in which I'll explain you the actual mean method, how we can apply actual mean method in certain situations. Like this is the question. Now the question is, you have been given n equals to 10, summation x is 350, summation y is 310 and summation x minus 35 whole square, that is equal to 162. Summation y minus 31 whole square, that is equal to 222. And summation x minus 35 and y minus 31, that is equal to 92. You have to find regression equations. So if you just look at this question, you'll think that this is a question of assumed mean method, because here we have deviations from 35 and deviations from 31. But if we say we have been given summation x and summation y, and if we find out the mean, so mean is summation x upon n. So that is 350 upon 10. That means 35. That means mean is 35. So this is the deviations taken from mean. And y mean is 310 upon 10. That is 31. So that means in this case, this is not dx square. This is summation small x square. And this is summation small y square, deviations from actual mean, and this is summation x y, that is 92. So in that case you don't need to apply shortcut method, you have to apply actual mean method. So bxy is summation xy upon summation y square. So summation xy is 92 and summation y square is 222. So if we divide 92 with 222, we got 0.414. And if we want to compute b by x, then this is summation xy upon summation x square. So summation xy is 92 and summation x square is 162. So this is 92 divided by 162. So this is 0.568. So this is the value of bxy and byx. Now you can easily find out the equation x on y. X minus x mean is 35. Bxy 0.414. Y minus y mean 31. And y on x, that is y minus y mean, that is equal to b by x 0.568 x minus x mean. So by solving this equation, you can easily find out the equations x on y as well as y on x. Now there is another concept which you must know, that is sometimes we have been given equations. We have been given equations and we don't know how to find out which one is x on y and which one is y on x. For this, you must know one concept. I have already told you in case of correlation coefficient that correlation coefficient is geometric mean of regression coefficients. That is, correlation is square root of bxy into byx. So that means bxy is 0.414 and byx is 0.568. So your correlation is 0.414 into 0.568 square root. So your correlation is 0.485. So this is correlation. So the next concept is, like we have been given two equations, 3x plus 2y equals to 26 and 6x plus y equals to 31. I don't know which equation is x on y and which one is y on x. So in that case, we have to make assumptions. Suppose this one is x on y and this one is y on x. If this equation is x on y, then take x on left hand side and put the remaining values on right hand side. Then x is equal to minus 2 by 3y plus 26 by 3. So whatever the coefficient of y, that is your bxy. So that means bxy is minus 2 by 3. And similarly, if this is y on x, then 6x plus y equals to 31. So whatever the dependent variable is, keep the dependent variable on left hand side and move another variables on right hand side. So that means the coefficient of x is your b by x. So how we can find out that our assumption is correct? In that case, you have to find out coefficient of correlation. And coefficient of correlation is geometric mean of regression coefficients. So if I put the value of bxy, that is minus 2 by 3 and byx, that is minus 6. So this is 3 2s are 6. Make sure, bacha, there is one property which I will explain you, that regression coefficients must have same algebraic sign. Either both are positives or both are negatives. And correlation coefficient should also have the same sign. That means your correlation coefficient is minus 2, which is greater than 1. And I have already told you that correlation coefficient always lies between minus 1 and plus 1. That means it is exceeding our limits. So that means our assumption is wrong. In that case, we have to flip our assumption. That means 3x plus 2y equals to 26. This is y on x. And 6x plus y equals to 31. This is x on y. So if it is y on x, so this becomes 2y equals to minus 3x plus 26. So y is equal to minus 3 by 2x plus 26 by 2. So my byx is minus 3 by 2. And this is x on y. So this becomes 6x equals to minus y plus 31. So x is equal to minus 1 by 6y plus 31 by 6. So my bxy is equal to minus 1 by 6. So now again I have to find out correlation. That is square root of minus 3 by 2 into minus 1 by 6. So this becomes minus 1 by 2, which is within my limits. So now my assumption is correct. So that means first you have to assume any one as x on y and second is y on x. You have to find out bxy and byx. Then find out correlation. Correlation is geometric mean of regression coefficients. So when we compute correlation, if it lies within the range, that means your assumption is correct. And if it lies beyond the range, that means your assumption is wrong. You have to flip your assumption. So this is how you can identify which one is x on y and which one is y on x. So now we are moving towards the last concept, that is properties of regression coefficients. Properties of regression coefficients. Just as we have explained the properties of coefficient of correlation, similarly we have different properties of regression coefficients. Now first property of regression coefficient, as I have already told you that the geometric mean of regression coefficient is coefficient of correlation. So first property is coefficient of correlation is geometric mean of regression coefficients. If we take any example like actual mean method, bxy is summation xy upon summation y square. Byx is summation xy upon summation x square. If we take a square root of this, then this becomes summation xy whole square upon summation y square into summation x square. So this becomes summation xy upon square root of summation x square into summation y square, which is equal to coefficient of correlation. So first property is coefficient of correlation is geometric mean of regression coefficients. Second property is regression coefficients and coefficient of correlation. All three must have same algebraic sign. All three must have same algebraic sign. That means either three are positive or all the three are negative. It's not possible that either one of any one of it is positive, rest two are negative. It means they all must have same subalgebraic sign. Either all the three are positive or all the three are negative. Next property is, we'll say the geometric, the product of regression coefficients should always be less than 1. Okay, the product of both the regression coefficients should always be less than 1. Only then the geometric mean should be less than 1. Fourth property says the average of regression coefficients should always be greater than equal to coefficient of correlation. So average of regression coefficients should always be greater than equal to coefficient of correlation. Next property we have, that is regression coefficients are independent of change of origin but dependent on change of scale. So what it means, you have to understand. I have already explained you the meaning of change of origin. Change of origin means addition of a constant or subtraction of a constant. And change of scale means multiplication of a constant or division of a constant. So they say regression coefficients are independent of change of origin, means they are not affected by adding or subtracting a constant, but dependent on change of scale means it is affected by multiplication or division of a constant. So suppose you have been given u, that is x minus a upon b, and v, that is y minus c upon d. So what we have done, we have x series, we have subtracted a from each element of the series and then we divided by b. Similarly, in the case of y series, we have subtracted c and divided it by d. Now the formula is rxy, that is equal to, not r, this is b. So we'll say bxy, regression coefficient of x and y, that is equal to, how we can compute, that is x. The scale of x is b, which is dependent. So this is b is in the numerator, and scale of independent variable, that is in denominator, into b u v. In this way you can find out the value. And if you want to find out b by x, then scale of y is in the numerator and scale of x is in the denominator into b v u. So this is the way you can find out regression coefficients of uv and regression coefficients of yx. Now suppose we'll take one example. Suppose the example is, we have been given 2u is equal to 2u minus 3x plus 5 equals to 0. And 5v minus 4y plus 11 equals to 0. If regression coefficient of xy is 0.79, find regression coefficient of uv. So first, in this case, take u on the left hand side and remaining equation is on right hand side. Now this is my equation. Now the coefficient of u should be 1. So divide the right hand side by the coefficient of u. So this becomes this. So if I say u is equal to 3 by 2x minus 5 by 2. So understand one thing. What is b? This is your a. What is b? The inverse of coefficient of x. This is your b. That means b is equal to 2 by 3. Similarly, in this case, 5v equals to 4y minus 11. So v is equal to 4 by 5y minus 11 by 5. So in this, what is d? That is inverse of coefficient of y. So d is 5 by 4. Now suppose if bxy is given, how we can find out buv? So bxy is equal to, the coefficient of x is, scale is, x is b upon d into buv. So bxy is 0.79, b is 2 by 3, d is 5 by 4 into buv. So 0.79 equals to 2 by 3 into 4 by 5 buv. So what is buv? This is 0.79 into 15 upon 8. So if we calculate 0.79 into 15 divided by 8, this becomes 1.48. And similarly, if we have given byx, that is 0.39. So how we can compute bvu? byx equals to d upon b into bvu. So byx is 0.39, d is 5 by 4, b is 2 by 3 into bvu. So bvu is 0.39 into 2 by 3 into 4 by 5. So we'll multiply it with 8 by 15. So 0.39 multiplied by 8 divided by 15. This becomes 0.208. So this is how we can compute the value of buv and bvu on the basis of given value of bxy and byx. So this is a very important property, that is regression coefficient is independent of change of origin and dependent on change of scale. And last property is regression coefficients are asymmetric. Regression coefficients are asymmetric. Now what is the meaning of asymmetric? The meaning of asymmetric is bxy is not equal to byx. As in case of coefficient of correlation, they are symmetric. rxy equals to ryx. So they are asymmetric. So this is the entire content of regression that we have discussed in one class. So the properties of regression is very important, and the most important property is this: regression is independent of change of origin and dependent of change of scale. So that's all about our regression. Thank you.